To navigate a single day, you likely tap a piece of glass to pay for coffee, pull up a high-resolution 3D map of your city, and stream 4K video. We manage almost every part of modern life through this one device. But long-distance communication used to require massive physical infrastructure. In 1837, Samuel Morse's telegraph meant routing electrical signals through heavy machinery and fixed wires. It took over a century to remove those wires. On April 3, 1973, Motorola engineer Martin Cooper stood on a New York sidewalk and made the first public handheld mobile phone call. By 1983, that prototype became the commercial Motorola DynaTAC 8000X. It weighed 790 grams. It required 10 hours of charging for 30 minutes of talk time and held exactly 30 phone numbers. This chart tracks a specific engineering trend. As the physical mass represented by the blue line drops toward zero, the utility of the device in yellow rises toward infinity, a pattern known as the shrink and expand paradox. The phone physically disappeared into our pockets even as its internal features multiplied. During the 1980s, the first-generation analog networks provided poor voice quality and limited coverage. Because of the high cost, these early bricks were used almost exclusively by business executives. In the 1990s, 2G digital networks arrived. Digital signals required less power, which allowed manufacturers to use smaller batteries and reduce the overall physical footprint of the phone. By the year 2000, devices like the Nokia 3310 hit the market. It was small enough to fit in a pocket and featured a battery that could last for several days. This digital shift also introduced SMS text messaging, adding the written word to the phone's capabilities for the first time. By shrinking the hardware and adding text, the industry turned the mobile phone into an affordable tool for everyday consumers. 3G networks in the 2000s introduced mobile internet, email, and music downloads. The line between a phone and a computer began to blur. In 2007, the launch of the original iPhone changed the hardware requirements again. Apple introduced a large multi-touch display and a full web browser, supported by a growing ecosystem of downloadable apps. Then in 2008, the HTC Dream arrived as the very first Android phone. This operating system gave other manufacturers a way to build affordable, customizable smartphones for the global market. These software innovations led to the removal of the physical keypad, reducing the front of the device to a single piece of glass. Software took over the interface, allowing the physical hardware to act as a blank slate for any application the user needed. 4G LTE arrived in the 2010s, providing the high-speed data connection needed for online gaming and high-definition video streaming. This speed fueled the growth of platforms like YouTube and Instagram, making the consumption of visual media the primary use for most phones. To support this visual content, the trend of shrinking hardware reached a limit. As this chart shows, phones grew larger to accommodate bigger screens. However, internal components continued to compress. While screen size grew on the X and Y axes, the device's thickness dropped, creating room for high-density batteries and processors. The physical hardware was now entirely designed around the digital content it delivered. Today's 5G era brings ultra-fast connections to minimalist glass slabs, powering everything from AI-assisted photography to cloud gaming and smart home controls. Under that glass sits an array of high-resolution cameras, biometric face unlock sensors, and massive digital storage. The 1983 Motorola could store 30 phone numbers. A modern phone provides instantaneous access to the sum of human knowledge. Today, these devices function as the universal remote controls for human existence. As technology continues to scale, the hardware will continue to minimize, eventually running the world silently from the background.